folks. We're so glad to have Lingshu here to talking about NTP today. Welcome.
Thank you.
Hi, Lingshu. I've heard of near data processing (NDP). As the name suggests, it refers to the paradigm of processing data at the source rather than shipping data to the processors. So can you tell me what does NDP mean typically in the context of a cloud-native database management system?
Oh, yeah. Cloud-native database systems typically employ designs of which compute and storage are placed into separate distributed tiers that scale independently. Huawei GaussDB for MySQL is such a cloud-native database system. We named the cloud servers Huawei GaussDB page stores. The page stores are a large fleet of powerful servers. In addition to serving data to compute nodes, it also can pre-process data for the compute nodes. The page stores filter out unnecessary data and only return matched data subset to the database nodes for further processing. So GaussDB can push 3 kinds of SQL operations into page stores. The 3 kinds are column projection, predicate evaluations, and aggregations. For column projections, the page stores make a narrower row by keeping only the columns needed by the query and discarding the rest of columns. For predicate evaluations, the page stores will keep only the rows that satisfy the predicates and discards rows that don't. Aggregations, the page store aggregate multiple rows into a single row and as required by the aggregate functions in the query and discard the original rows. So the 3 kinds of SQL operations can appear in any combination in NDP. For example, an NDP operation may contain only column projection, but it also can contain all 3 SQL operations. We can take a look at a sample SQL query here. So we have a table. It's named worker table. The table contains the worker's age and on what date he joins the company and so on and so forth. The query is to select the rows that satisfy conditions such as the age is less than 40 and the join date is between a certain range. And then we want to know the aggregate sum of the salary of these workers. And we also want to know how many workers there are that satisfy these conditions. So the page store will basically evaluate the predicate first. It will look at each row and basically evaluate the predicate age less than 40 and join date is between such and such. And if the row doesn't satisfy the predicate, the row will be discarded immediately. If the row satisfies the predicate, it's aggregated into this aggregate function sum and count, right? Original one is discarded. And if for some reason the page store cannot aggregate this row due to some internal processing requirements, it can still do the projection. So as you see, in this query, we require 3 columns, right? We require salary, age, and join date. And they can project the 3 columns and produce a narrow row. And after this, the original row is discarded. So at the end of the day, it's a significantly reduced data set that is returned to the database node.
Right. So the page stores are no longer just a dumb storage. The storage, they become smart and they can perform SQL operations too, right? So that sounds very interesting. So what are the benefits of doing so?
Well, since in cloud-native database system, even though the compute node and the page stores are connected via low latency RDMA network, the latency is still quite high compared to local storage in a traditional database system. So to reduce the number of I/Os can help reduce the negative impacts of network latency. In NTP feature, we implemented the concept of a batch read. The batch read is to group multiple pages into one single I/O request. So compared to the batch read that happens in other database processing contexts, our batch read is specifically designed for NDP, and it can afford to be very aggressive, and it can often group about 1,000 pages into one batch. Last but not least, since the page stores do some SQL processing on behalf of the compute node, the CPU resources at the compute node can be freed up and can be used to process more SQL statements. At the end of the day, actually, the benefits are performance. So with NDP, the cloud-native database system can achieve fast query response time and higher query throughput.
Great, and that sounds very attractive. But from what you described, NDP means that it seems like it benefits owning the large-scale large table scans, which usually happen in OLAP workloads. So what about customers who run OLTP workloads? Like, can they get benefits as well?
Oh, you're absolutely right. NDP benefits large scans. In fact, we implement NDP so that the system automatically decides what query can benefit from NDP and only trigger NDP for those queries. For customers who primarily run OLTP workloads, but also occasionally needs to run queries that do large scans, such as to count the number of rows in a table, NDP is automatically triggered for those queries, and those queries can benefit from NDP. And as I mentioned previously, since page stores would do some SQL processing for the occasional large scan queries, so the CPU resources at the compute node can be freed up and handle more OLTP statements. That's how OLTP customer can benefit.
Great. So I heard that Huawei GaussDB has like parallel query feature.
Yeah.
Does NDP work together with parallel query?
Oh, absolutely. Parallel query enables parallelism at compute nodes, exporting multiple CPUs to work for a query concurrently. NDP can engage multiple page stores to simultaneously work for a query. And also within a query store, multiple threads can be used to serve NDP requests. NDP and the parallel query, they can work together. NDP can be enabled for some of the scans that are performed by the parallel query worker threads. By combining NDP and PQ, PQ stands for parallel query, we unleash the power of parallelism in 3 layers GaussDB system. So in the compute nodes there, among page stores, and within a page store. So the results in further improvements to query performance.
Great, I've learned a lot, and that's very exciting. Thanks for watching this episode of Cloud Focus. I hope you like it. Please scan the left QR code for more documents about Huawei Cloud technologies and the right QR code for more help in a Huawei Cloud Developer Forum. There's more to come, so stay tuned. I'll see you next Wednesday.